Hello there. Before we continue with our series of functional notation, I wanted to take this time to talk about function notation. I think I said functional notation. I meant functional analysis. We're going to talk about function notation. What is it and why do we use it? Because it can seem like an aggravating thing. Usually we've gotten used to saying, well, y equals 3x minus 6. That's a perfectly acceptable way of writing an equation. Why would we use any other notation? Especially, why would we use one that's littered with extra letters and parentheses? And this is why. So first of all, what is function notation? It's this right here. It's the f parentheses x. And what this means is we read this as f of x. That's kind of the layman's terms of how we say it out. We don't say f parentheses x. We say f of x, okay? This does not mean f times x. We're not multiplying here. And naturally that can get confusing because if you put in a number, say f with the 2 instead of the x, this would read as f of 2. So why wouldn't we read that as f times x? It looks like parentheses are used for multiplication. We can undo that by dividing and solve for f. And I'll explain that in a second, but first things I want to address is f is kind of like x. It's just a notational thing. We can use any letter we want in place of x. We can use any letter we want in place of f. Typically, we won't use the same letters. We won't say x of x. That's not a thing we'll do. It'll always be 2 different letters. But again, it's just a notational thing. The general notation, we always start with a general notation and fill in the gaps as we need to change stuff. So let's say I wanted to solve y equals 2x, actually, no, sorry, 3x. I'll stick with my notes. 3x minus 6 at x equals negative 2. So let's say that was a problem I wanted to solve. Well, this is pretty straightforward. I can substitute x for negative 2, so I get y equals 3 times negative 2 minus 6. Y equals 3 times 2, negative 2 is negative 6. And I get negative 6 minus 6. That's the same as negative 6 plus negative 6. So we get y equals negative 12. Okay, that's pretty straightforward. Doesn't seem like we need function notation for that. And that's perfectly valid point. However, what if you were given a problem and that was all the information you were given? The function I gave you is not the only function that would yield negative 12 as an output for an input of negative 2. There are infinitely many graphs that can go through that point on a coordinate pair. So let's look at this instead. An alternate question we could be asked, same question, different wording, given f of x equals 3x minus 6, solve for, sorry, wrote too soon, solve for x equals negative 2. Okay, so that just means, again, I'm plugging in negative 2 wherever I see x. So I would say f of negative 2 equals 3 of negative 2 minus 6. And again, 3 times negative 2 is negative 6. Minus 6 gives us negative 12. Again, didn't need function notation to solve this problem. I was given a problem and I was given this. This tells us more. Again, there are still infinitely many curves that can give us an input of negative 2 that gets us an output of negative 12. The problem with this, the y equals negative 12, is that we don't even know that negative 2 is the input. That doesn't tell us anything other than what the output is. This gives us a reference for what the input is and what the output is. And now, while we still need more information, we can create a coordinate pair out of this, negative 2, negative 12, and we can plot that on a graph, and we can get more information. This does not tell us that, and that's why functional notation is preferable, and I'll be using this in all future problems. So let me know what you think about that. Leave a comment down below, like and subscribe, and I'll see you for the next video. Thanks for watching.